Hello everyone. In this video, I'm going to talk about another new concept called as weak entity sets. Okay. Now, weak entity sets, they are extremely popular, and they come in several business applications. Okay, so I would want you to pay specific attention here. Get this concept right. Okay. Now, what is a weak entity set? So, weak entity set is any entity set which does not have a primary key. In other words, what happens is that this weak entity cannot exist by itself in your application, right? And for it to exist, you must have an another identifying set via a total one-to-many relationship, right? So, for example, a very classical thing that we say is that, let's say that you're trying to uh, model birth numbers in coaches. Okay, so let's say that you're trying to design an railway reservation system, and you have this concept of birth numbers, right? And on these birth numbers, you will assign these birth numbers to people. Okay, now uh, if you pick any two coaches, let's say you pick two sleeper class coaches, they both will have the same set of birth numbers, birth number 1 till whatever 72 or something like that, right? So now this concept of birth in a train, it's a weak entity. It cannot exist by itself, right? So in order to uniquely identify a birth, you need to have some kind of an strong entity, or it needs to have some kind of a support, right? So now what is the first level of support that you can get? You will get coach number. So if I say birth number 10 in coach S1 and maybe birth number 10 in coach S2, right? So this is a classical example that the birth number by itself cannot cannot exist, right? When I say birth number 10 in train number 2022, what does that mean, right? The birth number is not very well defined. But if I say birth number 10 under coach S1, right, then it starts to make more sense, right? So these birth numbers, they are a classical example of a weak entity. You cannot identify a birth by itself, because there will be so many births with the same birth number, right? So in order to uniquely identify a birth, you need to have the concept of coach number, right? So now, given that we are talking about this railway reservation, let me go ahead and tell one more thing, that coach numbers are also not very well defined. Okay, birth number can be defined from a coach, but the coach number is also not very well defined. For in order to define a coach number, you have to actually go towards the train number, right? So if I say birth number S2, right, many trains have the coach number S2, right? But in order to uniquely identify a coach, you need to have the train number. Now, train number in a railway reservation system is a proper full-fledged entity, right? It exists by itself. It will have a primary key, which is the train number, and so on, because no two trains can have the same train number. Now, in a train number, the first level of weak entities would be its coaches, S1, S2, S3, AC coach 1, AC A2, and all that, right? So inside a train, you have this first level of weak entities, which are your coach numbers, and inside a coach, you will have the weak entities which correspond to birth numbers. Okay, so this is just an example. Now, what happens is, so that was the concept of weak entity. Now, when it comes to identifying a weak entity, we have this concept of what is called as an discriminator. Okay, so discriminator, or a partial key of a weak entity set, is the set of attributes that distinguishes among all entities of the weak entity set. So, for example, if I go back to my coaches and train numbers. Now, inside a particular train number, let's say that you have a train number 2022. So inside that particular train number, I'm trying to identify different coaches. Now how will I do that? I'll have coach numbers, right? So S1, S2, S3, A1, A2, A3. So these are sort of, you can take these coach numbers to be a discriminator or a partial key inside. And this partial key is sort of a way to distinguish the different entities in that weak entity set. But if in the grand scheme, if you have to identify an weak entity by itself, then you pull the primary key from your supporting relation, right? So for example, in my train case, the if you, let's say that let's say you are just worried about the coaches, then the primary key of that coaches table will have the train number and the coach number. That combination will become the primary key, right? So this is the summary slide over here. Primary key of a weak entity set is basically the primary key of the strong entity on which the weak entity is dependent. So for example, coaches are dependent on the train number, right? So the primary key of the strong entity plus the weak entity sets discriminator, right? So you should remember this, especially when you're trying to convert a weak entity uh, a weak entity set into a table. This is how you have to set the primary key, right? So I'll have more examples, but just to give you a case here. Okay, this is how we are going to illustrate a weak entity set. So over here, loan is a strong entity. That means it can exist by itself, right? So it will have a primary key. In this case, the loan number is the primary key. That means given a loan number, I can identify all the loan parameters of that loan. Now, a loan entity set, I'm saying that there are several weak entities, that there are several payments which correspond to this loan, right? So now all those payments together will become an weak entity set, right? So and each payment, you have the payment date, payment amount, and payment number, right? And all these payments, they correspond to a particular loan, right? So if you have to capture this information, what we have to do is so you make payment as a weak entity, and the way we represent a weak entity is that we put double rectangle and we connect that weak entity in a many to one relationship from here to the strong entity. This you should very strongly remember, right? uh, in fact, right, in your Ullman textbook, instead of this bold arrow, they even actually make it a curved arrow, making it mandatory that whatever strong entity it's referring to, that actually exists, right? And even this relationship, it has to be a double diamond, right? So make sure you remember this scheme of representing weak entities very nicely, right? Now if you see this dotted line, this represents payment number in this figure. That this guy represents the discriminator or the partial key of the payment weak entity, right? So now what it means is that for any one particular loan number, I will have several payment numbers which are associated with that loan, and amongst all these payments, the payment number is sort of the discriminator, right? By itself, the payment number cannot identify this payment fully, right? So it's very similar to a coach. You have a coach number which sort of distinguishes different coaches which are available, right? But the coach number by itself cannot uniquely identify that concept. It needs to have the loan, right? So we don't write the loan number here again, right? So that will be incorrect. So if you put loan number as an attribute over here, that will be considered as a wrong diagram. You have to say that payment is a weak entity of the loan, and for this weak entity, I have the following discriminator, right? So now when this guy gets converted into a relation, then what happens is that you, of course, you will create a table for loan, you'll make loan number as the primary key, and this part is trivial, that there is no big deal. And now for this part, what happens is you create a table for payment, you put this attribute fine, and this attribute as well. And what you do is that you pull in the primary key from here and put that here in the table schema, not in the diagram. And then you make the loan number and the payment number as the primary key for this particular table, right? So that's how you convert an weak entity into an table in your schema. Do not write loan number here in the ER diagram. Just that will be wrong. It is very well understood that when an weak entity is converted into a table, it will automatically pull the primary keys from its supporting relation. So over here, loan is considered as the supporting relation for the payment, right? So when a weak entity gets converted into a table, it the primary key of that table is the combination of two things. So one is its own discriminator and all the primary keys of the table which are supporting that weak entity, right? So over here, I just have one entity which is supporting payment. It can happen that payment can have more than one supporting relations also. I'll have an example in that, right? Okay, moving on. Okay, so this slide is just a summary of what I just covered right now. As I said, primary key of a strong entity set is not explicitly stored in the weak entity set, at least in the in the diagram way. But when you convert this ER diagram into tables, then the primary key of the strong entity set, or I know a better word would be the primary key of the supporting entity set, comes to the table corresponding to the weak entity set. Okay, just give you more examples. Okay, so yeah, so this is another hypothetical academic system just to illustrate the concept of weak entity. So here there are departments, and then there are courses, and then I'm saying that let's say that we have an hypothetical situation where the course numbers are not unique across the institute, right? So in such a case, the courses become weak entities under the department. Of course, the academic system of IIT Ropar is different in the sense that course IDs are unique across the institute, but just take it with a grain of salt, that just as an example to illustrate weak entity set, right? Okay, so this is just yet another example. Yeah, so this example is much more relevant to IIT Roper system. So here we have a course which is a strong entity. That means a course can be identified uniquely across the entire institute using the course ID, right? So no two departments will have the same course ID, right? Now course ID becomes a strong entity, and on the with the course as the supporting entity, I can define course offerings as weak entities, right? So let's take one course, CS201, right? It will have several offerings. That means the course was offered several times. So now the course offering can be a weak entity which is sitting under the course as the strong entity. And what will be our discriminator? Now all these offerings, if you pick one course, let's say CS201, then all the offerings of CS201 can be distinguished among themselves by having a discriminator, and that discriminator would be our semester and year. If there are multiple sections, then maybe the section number will also become the discriminator. The combination of those three will become the discriminator, right? So I think this is more relevant to IIT Roper academic system, a live example for weak entity, so to say. Okay, yeah. So here, I took this picture from your Ullman textbook. So you might remember this contracts multi-way relation between Star Studios and movies. I've been talking this for several videos now. So a multi-way relation can be converted into an weak entity like this. Okay, so over here the contracts relation is supported by three things, stars, studios, and movies, right? So so that means for a contract to exist, I should have one primary key from here, one primary key from here, and one primary key from here, right? So this is how, and in your Ullman textbook, that I'm putting a circle like this, which means that the prime the tuple which the contracts guy is pointing to must exist, right? So now this falls little bit into design decisions and all that. Let's say that you have a case where in some contracts some of these values can be null, right? So that thing does not really it will not pan out nicely, right? It will not look good. So the reason I'm saying this is that do not think that a multi-way relationship is equivalent to an weak entity, right? That's not how it goes. You have to take these things with a pinch of salt, and for whatever application that you are developing, you have to make the best judgment, right? Sure, some multi-way relationships can be converted to weak entities, something like this, but there are lots of assumptions which go in, and lots of constraints you have to take care. You have to really go with what is best for your business logic, right? I'm just showing it as an example, but don't take it as written on stone that all multi-way relationships can be directly converted into an weak entities. By no means you should take that as the assumption. Okay, just see that this is just an illustrative example. Okay, okay. So I think I covered this informally multiple times, right? So as I said that when you convert a weak entity set into a table, it should include the key attributes of the supporting entity sets. Okay. So that means that and and the key for the weak entity set would be the combination of the uh, primary keys of the supporting entity sets and whatever discriminator it has. The whole combination will become the primary key of the weak entity set. One more thing, when you have weak entity sets, there is no need to convert these double diamonds into tables, right? You might remember that previously when I started this module, I said that all rectangles gets converted to tables and all diamonds also gets converted into tables, right? But for weak entities, this is converting these things are not really needed, right? And I think we saw yet another example where there was a many to one relationship, and then I think then also we did not convert, right? So when you convert this into tables, you'll have tables for stars, studios, and movies, and you'll have all the primary keys defined, and then you will have one more table for contract, and attributes of this particular table will be name, keys from here, basically star's name, studio's name, and movie title and year, and then salary also, right? And the primary key for the contracts weak entity would be the combination of uh, name, star's name from here, studio name from here, and movies from here. Okay. Okay, I think that's all for now. I'll stop here. But I would like you to. So this is a design process. It's subjective, I understand, but hopefully you got a gist of how to do a good database design. Okay, thank you.